Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called EPSA Leftover number 8, Sum or Product Frame by Richard. And here are the rules. Apply classic Sudoku rules, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Clues excuse me. Clues outside the grid indicate either the product or the sum of the first 3 digits in the corresponding direction. So if this were to be a sum, you could have something like, say, 3, 6, and 1, and that would satisfy that of the first 3 digits. Or if this is the product of the first 3 digits, it could be something like 2, 5, and 1 here, and that would satisfy that. So the digit outside of the grid is the sum or product of the first 3 digits. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so there are a couple that are pretty obvious. These are products, these are products. So let's, this will mark as, products will mark as green, and sums will mark as plus. This is a product also. So those are the ones that are definitely products. You could have anything from 6 to 20 be a sum. Sorry, 6 to 24 be a sum. And they all actually can be multiplications. So that's interesting. What we do know here, though, is this is going to be 1, 2, and 3 here. Because it's not a sum, and it's not... As a sum, it has to be 1, 2, 3 added up to 6. As a multiplication, it must be 1 times 2 times 3 multiplying to 6. So either way, this is 1 through 3. This could be a multiplication or it could be a sum. Anyways, the remaining digits in this row then are 4 through 9. Okay. This cannot be a multiplication. Because if this were a multiplication, it's minimum 4 times 5 times 6. Which is like 100 and... It's a lot. 120? 24 times 5. Yep, 120. So this has to be addition here. So we know that's addition this way. This could be multiplication there. Okay, multiplying to 72. What are the possibilities? 72 is 2 to the third times 3 squared. So we can have 2 3 times, or 3 2 times, and we have to have 2 represented 3 times, and then 3 represented 2 times. Obviously, it could be 1, 8, and 9. What else? What can we not have in that? We can't have 5 and we can't have 7. Everything else, I think, is fair game. So, and we have this multiplying to 3. Sorry, this multiplying to 72, this multiplying to 72, and this multiplying to 72, which means 5 and 7 cannot be any of those digits, which means this must be a 5-7 pair here. So we have 1, 8, 9. We have... And they can be used multiple times. 1 can only be used with 8 and 9. Because, yeah, you can't get 72 any other way with 2 digits multiplying to 72. What else can we have? 2. So all of them have to be part of something that multiplies to 72. So 1 can only be with 8 and 9. 2 can be with, so that means the others multiply to 36. You can't get 6 and 6. So it would have to be 2 must be multiplied with 4 and 9. So 9 is doubled up once. So that means one of these is a 9. What's the other one? Okay, so then we have 3. 3 must be 3 divided by... So again, we have 189. Two, 4, 9. And 3, I think, has to be with 4 and 6. Right, because you can't have 3, 3, 8. Because that would duplicate the 3. So it has to be then 4 and 9 are the duplicates. Are the ones that are used twice. So I think that means this is 4, 9 as a pair, which forces this to be 2. So that's 2. And then one of these is 9, 8, and 1. And the other one is 4, 3, and 6. Okay. So we definitely have 2, 5, 7 here. That eliminates 2 in the rest of the column. Remaining digits in column 1 have to be 1, 3, 5, 6, 7, 8. To multiply to 48, you cannot have 5 or 7. This cannot, the remaining digits of row 2 cannot be 2, 5, or 7, so we have 1, 3, 4, 6, 8, 9. Can this multiply to 20 without a 5? No, so this must be a sum. And since this is a sum, we could have 3, 8, 9. We cannot have 4, 7, 9. So without 4 and 5 as the lowest digits, well, you could have 4. You can't have 5 as the lowest digit, so it has to be 3 or 4 as the lowest digit, because 6, 7, 8 adds up to 21. And 4 has to be with 7 and 9, which doesn't work. So this has to be 3, 8, 9 here. So we have 3, 8, 9 here, which eliminates 3, 8, 9 in the rest of the row. So we have 1, 4, 6 here. Okay. Multiply to 48. It could be 1, 6, 8. Could be quite a few things. Multiply to 15 is possible. 1, 3, and 5 work. You could also add to 15, though. Remaining digits of box 3. We have 1, 2, 4, 5, 6, 7. Okay. So 7's going to have to be in one of them. So it's going to have to add up to something because it doesn't multiply to 15 or 10. Let's see. What else can we have? So 10 would be, if it added up to 10 with 10, it would be 1, 2, and 7. Which would leave 4, 5, 6 on the other end, which does work. If it adds up to 15, what could it be? It cannot, it has to be 2, 6, 7, right? If that's the case. And then the other one could definitely, okay, yeah. 15 plus 20 plus 10 is 45. So these could work either way. So these are both sums, essentially. We don't know about this one. So again, this is 1 and 8 together, and 3 and 3 and 6 together with the 4. Excuse me. Can this actually add up to 15? 1, 5, and 3 or 6 does not work. 1, 7, and 3 and 6 doesn't add up. 8, 7 doesn't work, obviously, it's already 15. And 8, 5 doesn't work. So this has to be a multiplication also. And since this is a multiplication, it has to be 1, 3, and 5. Which means this can't be 1 or 3. This is 6, 8 as a pair. So this must be 5 here. This is 7. This 1, 3 pair eliminates 1 and 3 in the rest of the column. So this can't be 1 or 3. It's 2. Which means this can't be 2. And this can no longer add up to 20 because we have a 6, 7, 8 triplet in the column. So if it's 3, it only has 3 as a possibility to add up. So it would have to be 3, 8, and 9, but we can't have an 8 because of the 6, 8 pair in the column. So this must multiply to 20, which makes this 1, this is 3, and this is 4, 5 as a pair, which multiplies to 20. Because we need a 5, and therefore, because we need a 5, we have to have, it has to be 5, 4, and 1. So no 1 here, no 3 here, no 5 here. So these can't be 3 anymore. It cannot be 1, 6, 8 if this is... Well, we know 1 has to be one of these 3. So if we try to make it 1, 6, 8, we would have to have 1 here and then 6, 8 here, but that's not possible because this can't be 6 or 8 because of 6, 8 pair in the column. Actually, let's what are the remaining digits here? 2, 3, and 9. Remaining digits of box 7, we have 6 through 9 there. Remaining digits of column 3, we have 4, 6, 7, 8, 9. Obviously, 7 cannot be here to multiply to 48. 48 cannot have 9, right? Yeah, it doesn't divide evenly by 9. So it's 2 or 3. If you had 48 divided by 3, it has to be 2, 3, and 8. That doesn't work, though. Because you can't have 2 and 3 both have to be here. So 3 can't work, which makes this a 2. So we have 2, and then one of them is 6. And the other must be 4. So it's 4 and 6. This can't be 4, so that's 6. This is 4. So that eliminates 2, 4, and 6 in the rest of the box. And 6 eliminates 6 here, so it's a 7, 8 pair, which eliminates 7, 8 in the rest of the column. And box, so this can't be 7 or 8. It's 6, 9 as a pair, which means this can't be 9. Okay. To multiply to 20, you would need 1, 5, and 4. You'd have to have 5, and then the rest must multiply to 4. And we don't have 2 or 4 available, so this cannot multiply to 20. It must be a sum, adding up to 20 here. So it could be 3, 8, 9, or 5, 7, 8. Which means we're guaranteed an 8 in one of those 3 digits. The remaining digits then must be 1 with either 3, 9 or 5, 7. Okay. This must either... You can't multiply to 15 on either side. You can't multiply to 15 on this side, I should say. That would have to have 1, 5, and 3 to multiply. You cannot multiply to 18 here because you need an even digit and you need just a 2 with a 9. So that doesn't work. So this must add up. So these must be sums. It does add up to 12 here, so that's fine. Can we ever have 9 here? No, because it's 9, 1, and 7 at minimum then, which is greater than 15. So this must be 3 here. So we have to have 3 here, and these two must add up to 12, which is 1 cannot do. So this is 5 and 7, which forces this to be 9, 1, and 8. Okay. This can no longer add up to 24 because we have a 7 in the row, so this must multiply to 24. It does not have a 3 available, so it must be 1, 4, and 6 instead of 1, 3, and 8. So this is 1, 4, 6 as a triplet, which eliminates 1, 4, 6 in the rest of the row. So this is 2, 8, and 9, which eliminates 9 here. So this cannot be 3, 9 here. It's 1, 5, 7, which eliminates 1, 5, 7 in the rest of the row. So this is 3, 8, and 9. Therefore, this must be 2, 5, and 7, and they add to 14. That leaves this as 3, 4, 6 here. Okay. 18s. That's a lot of 18s. So this must be adding to 18. We don't know about these. Don't know about that going down or that going down. Can you multiply to 20 or 12? It could be 1, 3, 4. 18 would have to be 1, 3, 6 or 1, 2, 9. Um, some could work at 3, 4, 5. Okay. So this is multiplication. This is whatever. We don't really care. It's the same thing. Okay, we have 18, 18. Remaining digits of row of box 2. We have 2, 3, 5, 7, 8, 9, right? These are sums, no matter what, right? 1, 2, you can't get 1, 2, and 5 here. That would force the other side to be 4, 6, 7, which does not add up to 15 or multiply to 15. So this must sum to 10, which is 1, 2, 7 or 1, 4, 5, I believe, right? Yeah, if this is not 7 here, this must be 7 here, which means these must add up to 8 for the 2 digits, which would be 2, 6, which would be 1, 4, 5. So this is either 1, 2, 7 or 1, 4, 5. Either way, you are guaranteed a 1, so this cannot be 1. This is 3, that's 1. And again, to multiply to 72, it must be 1, 8, and 9. That leaves this as 4, 6, and 3. So this cannot be 3 here. We cannot have 8 or 9 here. We are guaranteed 1 here. This cannot be 1, 4, and 5. It's 1, 2, 7, which eliminates 1, 2, 7 in the rest of the row. So this is 5, 8, 9 as a triplet. This cannot be 1, 2, or 7. It's 4, 5, 6. That means this cannot be 5 here. It's 2, 3, and 7. Interesting. Okay, so can we add the 12 here? We can multiply to 12. 1, 3, and 4 does work. Can we add to 12? 9 doesn't work because that would require 1 and 2 on both sides. Not 8 doesn't work. It would be 8, 1, 3. 3 doesn't work because you have so say you have 3 and 7 here, it would require 2 there. If you have 3 and 2 here, that would require 7 there, which is 2, and these are digits would be too small. So this must multiply to 12 going down. So this must be, it can't be 1, 2, 6 because this cannot be 2 or 6. It would have to be 3 here, which just makes this 4 and 1, which eliminates 1 and 4 here. So that's 6. There's no 6 here. No 4, no 3 here. No 1 here. This can no longer multiply to 15, so this must sum to 15 here. Which would mean 2, 5, and 8. So this is 2, 8, and 5, because that's the minimum there. 6, 9, and 7 then. This cannot be no 3 here. No 9 here. No 8 here. No 5 or 2 here, so this is 7, which eliminates 7 in the rest of the box. This can't be 4 or 6 anymore here. This cannot multiply to 18 without 1, 3, or 6. So this must add up to 18 also. So this adds up to 18 and this adds up to 18. Remaining digits of column 9, 2, 5, 7, 8, 9. So we know 7 has to be one of these 3 digits. Since that's 7, the remaining 2 digits must add up to 11. So that's 7, 2, 9, no 3, 8, no 4, 7, no 5, 6. So it must be 7, 2, 9 here. So eliminate 7, 2, 9 in the rest of the column. This can't be 2. This is 5. This can't be 5. It's 2. This can't be 9. It's 8. Which makes that 3, which makes that 9. So 7 and 9 cannot be any of these digits. This can't be 8 because of 8 in the column. No 5 because of 5 in the column. No 6 here because of 6 in the column. So 18 here as a sum. If this is 4, that would force this to be 6, which would be 10, plus 8 would have to be there, but they can't be there, so this cannot be 4. Can you ever have 9 here? Yes. If you have 9 here, it's 4 and 5. If you have 7 here, it's 6 and 5. You can never have 9 with 8, because this can't be 1. No 7 with 8, because this can't be 3. So this can't be 8, therefore this is 5. And 4, 9, or 6, 7 there, which means this cannot have a 5 here. Can this multiply to 18? Yes, 1, 3, and 6 is possible here. And this could be 1, 2, or 9. Remaining digits of column 8, we have 1, 4, and 8. Remaining digits of column 7, we have 1, 4, 6, and 3. So we definitely have a 3 here. Can this ever add up to 18? And the answer is no. Because 3, 4, and 6 at max add up to 13. So this must multiply to 18, which is 3 with 1 and 6. So therefore, this is 6. This has to be a 1, 3 pair. That eliminates 1 in the rest of the column. So this is 4, which makes that 1. So this cannot be 1 here. And we can't multiply to 18 here because it would have to be 2 times 9 times 1. So this must sum to 18. So this is 6 and 5, which forces this to be 7. So there's no more 7 here. This can't be 6 or 7 here because of 6, 7 in the row. Therefore, you cannot have 2 here because that adds up to a maximum of 13. So this must be 9. That's 2 there. 9 plus 3 and 4 does not add up to 18. This cannot, and 1, 4 does not add up to 18. So this can't be 4. It must be 8 and 1 here, which makes that 3 and 4 there. So that's done. This is done. 15. Okay. So which ones are done? So 9 times 8 times 1 is done. That multiplies to 72. So does 9 times 2 times 4 multiplies to 72, as does 4 times 6 times 3, and 1 times 5 times 3 multiplies to 15. 5 plus 8 plus 2 adds up to 15. 1 times 3 times 4 multiplies to 12. 4, 5, 6 adds up to 15. 3, 8, 9 adds up to 20. 1, 7, 2 adds up to 10. 5, 3, 7 adds up to 15. 1, 6, 4 multiplies to 24. 6, 2, 4 multiplies to 48. 1, 9, 8 adds up to 18. 3, 8, 9 adds up to 20. 5, 2, 7 add up to 14. 9, 8, 1 adds up to 18. 7, 2, 9 adds up to 18. 7, 5, 6 adds up to 18. 6, 3, 1 multiplies to 18. 1, 4, 5 multiply, and this 4 eliminates 4 here, so it's 5 and 4. 9 eliminates 9 here, so it's 6 and 9. 8 eliminates 8 here, so it's 7 and 8. And 3 plus 1, 1 times 5 times 4 multiplies to 20. And 3 plus 1 plus 2, or 3 times 1 times 2, add or multiply to 6. So we just have these two left. Remaining digits of row 7, we have 2, 3, 5. Remaining digits of row 8, we have 1, 6, and 7. Okay. So we don't know if these multiply or add to 20. Can this add to 20? Well, okay, can it multiply to 20? No. If we try to multiply this to 20, it's not going to work, right? It needs to be 5, 4, and 1. And this can't be 1, 4, 5. So this must add to 20. You can't have 2 here, you can't have 3 here, so this must be 7. But... and it has to be 7, 4, and 9. Right? If you have 20 minus 7, it's 13. You have either 4, 9, or 5, 8, and this cannot be 5 or 8, so therefore it must be 7, 4, 9. Okay, this cannot be 4 or 9, it's 8. That means these can't be 8 here. This can't be 8 or 9, it's 2. So no 2 here, no 7 here, no 7 here, and no 4 here. Okay. No more 9s, no more 4s, no more 7s. Can this add up to 15 anymore? 1 would have to be with 5 or 9 or 6 or 8, so this could not be 1 in that case. 6 would require the remaining digits add up to 9. And you would have, with 2, it would have to be 2, 7. 3 would be 3, 6, and neither of which works. So this must multiply to 15, which makes this 3, 1, and 5. So we have 3, 1, 5 here. That forces this to be 2, 6, 8. No 3 or 5 here, so that's 2. These can't be 2. No 1 or 5 here, it's 7. This can't be 3. This can't be 1 or 7. It's 6. That makes this not 6. It's 4. 4 eliminates 4 here, so it's 9 and 4. 6 eliminates 6 here, so it's 1, which makes this 7. 1 eliminates 1 here, so it's 5 and 1. 9 eliminates 9 here, so it's 8 and 9. This can't be 5 because of 5 in the column, so it's 3, which makes this 5, and 3 eliminates 3 here, so it's 6, which makes this a 3. And that's a solution. So let's double check, but okay, so this is an add. Well, we already did all those. We already checked actually all of them, so that's fine. 7, 4, 9 adds up to 20. 3 times 1 times 5 multiplies to 15. And that's a solution. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.